Hello everyone, this is Musammat Israt Jahan Rifa from Department of Economics of Shahjalan University of Science and Technology, Sylhet. Today I will talk about American derivative securities. So welcome to this video. In the first slide, we talk about American derivative securities, which is very important in real financial markets. In many basic financial markets, we assume that a derivative can only be exercised at a fixed future time, usually denoted by T. However, in reality, many financial contracts are more flexible. Specifically, American options allow the holder to exercise at any time between 0 and T, which we write as tau is greater and equal to 0 and t is less or equal to t. Here, tau represents the time at which the holder chooses to exercise the option. Now, this flexibility is extremely important because it gives the investor control over timing, but at the same time, it creates a challenge. The investor must decide when is the best time to exercise. So, unlike simple derivatives, pricing American derivatives becomes a problem of decision making over time, not just a direct calculation. Now, the next slide is about payoff structure and its example. Let's understand what the investor actually receives. For an American call option, the payoff is given here. For an American put option, the payoff is also given here. Here, S of tau is the price of the asset at the chosen time tau, K is the strike price. The plus sign means if the payoff is negative, we take 0, so the investor never loses from exercising. Now, the key insight is the payoff depends on both the price and the timing. So, the investor's decision is not just about the price movement but also about choosing the right moment to act. Now, coming in the next slide, which is about difference from European derivatives. To understand this better, let's compare with European derivatives. For a European derivative, the payoff occurs only at time t, so we only need f of s of t. There is no discussion involved. But for an American derivative, the payoff can occur at any time tau, so we need f of s tau, and tau is as usual greater or equal to 0 and less or equal to t. This means the investor has flexibility but also must make a decision. So European is about the passive one and the American is about the active one. This is why American derivatives are more realistic, because in real life people prefer having the option to choose the timing. And if we can say, European talks about the valuation and American talks about valuation and also with the optimal stopping. And so we must determine optimal stopping time tau star. And in the next slide, we talk about value function and optimal stopping formulation. Sorry. So, the main question: how do we price an American derivative? For an European derivative, pricing is relatively simple because the payoff happens at a fixed time. But for an American derivative, the payoff depends on when the investor chooses to exercise. So we must determine what is the best time tau to maximize the payoff. And mathematically, the equation is given here, but don't worry about the formula. It simply means choose the time tau that gives the maximum expected discounted payoff. So pricing becomes an optimization problem over time where the investor chooses the best strategy. And this is a stochastic dynamic programming problem. Then coming to the next slide, which is about dynamic programming and recursive valuation. To solve this, we use a step-by-step decision process. At time t, we compare two options: exercise immediately and receive f of st, wait and continue, and expecting the future value which is given here. So the value here is also given. Here actually we talked about two conditions: the terminal condition and recursive condition. Both are expressed by v, and terminal condition is expressed by v of the t with capital letter, and recursive equation is t of small letter. In simple term, is it better to take the payoff now or wait for something better? This comparison is made at every moment here. There are also economic meaning here, which are kind of exercise value and continuation value. At each time, decide whether to stop. If we stop, then we have to go for exercise, or if we continue, then we have to go for hold. So the investor is continuously making decisions over time. Now coming to the next one, which is binomial model implementation. Here we talk about the stock price dynamics. Here we talk about the stock price dynamic, risk neutral probability recursive pricing formula. Stock price dynamics is given as ST plus 1 equal to, in the upper side there is UST and in the lower side there is DST. Then we have the risk neutral probability which is expressed by Q, and then we can get the recursive pricing formula which is as usual expressed by V of t. There are also various algorithm involved here. We have to compute Vt equal to f of st. Then we have to move backward through t. We have to apply maximum rule at each node. And this was all about binomial model implementation. Then we have optimal exercise rule and properties. Here we have exercise decision. We can exercise if it holds the condition given here. Otherwise, we have to continue holding. There are also important properties which is given here. Here the American one is greater or equal than the European one. American call no dividends and early exercise is not optimal here. American put early exercise may be optimal. And in the optimal exercise rules and properties, we have mainly these discussions involved. Then we have the Snell envelope and final insights. Snell envelope presentation, here we presented the Snell envelope presentation by in mathematical terms, which is expressed as Vt, and this represents optimal value process, smallest supermartingale dominating payoff. And finally we have the final insight, which is American option value is equal to European value plus early exercise premium. And if we our slide is actually have come to an end, but if we talk about some real life intention, then let's connect this with real life to make it clearer. Imagine you own a house. Today you receive an offer, but you believe the price might increase in future. So you face a decision. Should I sell now or wait? If you sell too early, you may lose future profit. If you wait too long, you may miss a good current offer. This is exactly the same problem as an American option. And we can express this with another example. Suppose you have a limited time discount coupon. You can use it today or wait for a bigger purchase later. So you think, when will this give me maximum benefit? This is the essence of American derivatives, choosing the best time under uncertainty. And the value depend and actually in simple words, it's not just about what you get, it's about when you choose to get it. And this is why American derivatives are both powerful and widely used in financial markets. Hope you understand today's topic. Thank you for watching. See you soon again.